Okay, you'll sometimes be asked to solve something by using iteration. Iteration, just from the Latin word iterum, which means to do again, to do for a second time. So we've got an equation there, x squared plus 3x minus 2 equals 0. And you've already got the skills to solve that problem. You would not actually need to use iteration to solve this problem. If you're asked to use it, then use it. The steps essentially involve rewriting the equation in a form so that it's x equals something. For this one, I'd say x squared plus 3x minus 2 equals 0. That means x squared equals 2 minus 3x. Now I know that x is not equal to 0 because 0 plus 0 minus 2 is not equal to 0, so I can divide by x. X equals 2 over x minus 3. Now the iteration skill here is just to say that now the x is by itself. We'll write a formula, an iterative formula, x n plus 1 equals 2 over xn minus 3, which means if I now start with a first value of x, I input my first value in here, see what the answer is. Whatever the answer is, that's my next value of x, which I will input in again. Your calculator is very good for this. So we'll say that my first guess for x is x1 equals, let's say 1. Your calculator. I'm going to do an iterative process, so I want to not have to do too much typing. 1 equals. Now the calculator knows that 1 is the answer. Cancel that. And my iterative process is 2 over, so 2 divided by the answer, which I've just told the computer is 1, or the calculator is 1, minus 3. So I've got, the calculator now knows that my first iteration is 2 over 1 minus 3. So get the answer out. And the answer is minus 1. Then I repeat. The calculator will now automatically enter that answer into that formula and give me the next answer. The next answer is negative 5. Do it again. Negative 17 over 5. Now I was getting worried initially when it went to minus 1, minus 5, it was getting bigger. But now it has come back towards where it was just now. It's suggesting maybe it's going to converge to an answer. Let's just keep doing it. Equals, next one, negative 61 over 17. Now I don't know how close negative 17 over 5 is to negative 61 over 17. So I'll get this converted into a decimal form now. Press S to D on your calculator. I know it's hard to see that on the screen, but it's negative 3.5882. Negative 3.5882. The next guess, just do it again. So it agrees with x5 to 1 decimal place. Let's do the next one, x7 equals. Or we can just keep on going. Negative 3.56155. Negative 3.562. Negative 3.56 to 2 decimal places. I chose to start with x1 equals 1. And it took me to that solution. I could have made a different first choice. Let's now go back in and change my starting choice. Let's begin with -2. If I start with -2, I can now go back up. 2 divided by answer -3. The answer now is -2. So x1 is -2. Move over that side, sorry. x1 is -2. x2 is -4. S to D. S to D. Notice we're tending towards the same value. X is approximately -3.56. Now I know there are actually two solutions here, but with our method, using this iterative formula, using two different start points, 1 and -2, we have in both cases tended towards the negative solution, -3.56. In this case, though, we have at least converged to a solution. On occasion, we will diverge away from a solution. 8x cubed plus 6x squared minus 137x plus 165 equals 0. We want to solve that. Firstly, get the x cubed by itself. 8x cubed equals -6x squared plus 137x minus 165, then divided by 8. X cubed equals 1/8 times -6x squared plus 137x minus 165. And then we can say that x equals the cube root of 1/8 times -6x squared plus 137x minus 165. What happens here that cube root of 1/8 is actually a half. So I will do that bit, work out that bit, and then do the cube root sign around the rest. -6x squared plus 137x minus 165. And now we'll try some iterations using xn plus 1. So the next term is a half times the cube root of -6xn squared plus 137xn minus 165. I'll begin with x1 equals, let's say 1. My calculator, I need to get all of that formula in there. So 1 equals, my formula is 0.5 times the cube root, shift cube root of -6 answer squared plus 137 times answer times 165 equals. So x2 is -1.619 and repeat. Minus 4.85. It's becoming more and more negative, but it isn't accelerating away, which is always a good sign. X6, X7, negative 4.9836. It's still not accelerating, which is good. Looking promising. And it doesn't take much imagination at this stage to guess that maybe the answer is -5. And I know it is -5 because I set the problem up on purpose. Okay, I'll stop there. You can do the same starting with x1 equals -10. See what happens. And when you've done x1 equals -10, try x1 equals 4. Now with x1 equals -10, you should have found that your solutions tended again towards -5, but this time from the opposite side. So you end up with answers that are slightly more negative than -5 until eventually it tends towards x equals -5. If x1 equals 4, you should have found that your answers tended towards x equals 2.75. The different starting points can result in different solutions. There is actually a third solution, x equals 3/2. It's quite hard to get to x equals 3/2 using this approximation or this iteration method. So if we have an x squared function, 2x² equals, divide through by x, usually the best method. For an x cubed one, get x cubed by itself, and then apply the cube root to both sides. Let's look again at another x squared one. Given x squared minus 15x plus 4 equals 0, use an iterative method to find x. I'll pause the tape there for a minute to give you a chance to decide how you would deal with the x squared minus 15x plus 4 to create an iterative formula. If you want to, you can go ahead and do the iteration as well. Otherwise, wait for me to rejoin you. Okay. We're going to use an iterative method to find x. Iteration means for an x squared one in general, just rewrite it as x squared minus 15x plus 4 equals 0. Get x squared by itself. X squared equals 15x minus 4. Divide by x. X equals 15 minus 4 over x. The x is now by itself, so our iterative formula x n plus 1 equals 15 minus 4 over x n. Now we have to decide where we're going to start. We can start anywhere. Let's just try x1 equals 1. Calculator. 1 equals, and cancel. My formula is 15 minus 4 divided by answer equals, my first answer is 11. The second answer, 161 over 11. Let's turn that into a decimal, 14.636. Turn it into a decimal. I'm already quite pleased here because this is not going very far. step from here to here is quite a small one, which suggests maybe it's converging. I think we can say that x is approximately, and I think we can go 14.73 with confidence, to 2 decimal places. There's one solution. We think there are probably 2 because it's a squared function. Let's make a different starting guess. We started by guessing with x positive. We got a positive solution. We don't know whether the other solution is positive or negative. Let's guess to begin with x1 equals, let's try -5, see what happens. We've got -5 as my answer, -5 equals, then we go back up to, I'll cancel some, go back up to my function, it's 15 minus 4 divided by answer, that's the one. It now knows I've said -5 is the answer, so we'll start again. It goes straight to 79 over 5, about 14 and a bit, or 15. Okay, it looks like it's very likely to be going straight towards the answer I had before. So before I start writing these down, let's just see if we get straight to the same answer. Well, yes, we do. Okay, x1 equals -5 tends towards the same solution, 14.73. Okay. We don't know if the actual other answer is bigger than or smaller than. I'll try another negative one. Let's try x1 is let's try positive 0.1 equals, and then we've got back up to my formula, 0.1 equals, x2 is -25, x1, oh dear, 15, next one, 14.7, never mind, we again tend to 14.73. Now it can be very hard to know where you're going to tend towards, but that doesn't matter. You've certainly used the iterative method to find a solution. You've got one solution. If they want you to find the other solution, they would probably tell you where to start with your first iteration. So they either give you the iteration formula to use, or they will tell you where to start from. I'm happy enough with that one solution I've got. I won't even think about the other solution. I'll leave it there. So let's go on to give you a couple of problems to solve here. Just pause the tape there, and I'll be back with you in a couple of minutes. So if you've got those answers, well done. Nothing more for you to listen to. If you didn't, let's see what we need to do there. For the first one, they tell me that my x1 is to be 1. So in my calculator, I say 1 equals, and I cancel that. The iterative formula to be used is 2 plus 6 over the answer. So 2 plus 6 divided by answer equals. Now I get 8. Let's begin for question 1. x1 equals 1. x2 equals 8. x3 equals 11 over 4 equals 46 over 11. Now we want to start converting these into decimals so I can see when it starts to converge. 4.18. So x4 equals 4.1818. 3.6366. 3.645 rounds to 3.65. The next one rounds to 3.65. I think I get a bit confident now. X14, 3.6459. So I'm going to say that X is approximately 3.65 to 2 decimal places. Okay, for the second one, the formula they gave me is minus the square root of 2x plus 6. And they told me to start with x1 is negative 2. So begin, negative 2 equals, and cancel. There's my formula. Negative the square root of 2 times the answer plus 6 equals x2 equals negative root 2. x3 equals negative 1.78. Next one. Let's miss a few out now. Okay, we're getting very close to settled now. I've got negative 1.645. I think we can say x is approximately negative 1.65 to 2 decimal places. That's iteration.